It's my pleasure to introduce Jim McHugh, Vice President and General Manager at NVIDIA.
Great.
Welcome, Jim.
So good to be here.
Wonderful. Now, we're here talking about AI transformations in enterprise. Could you give me a bit of an overview of...
Yeah, I think we have to have a broader picture of an enterprise. I mean, enterprises do many things. They're in manufacturing, they're taking care of customers, they're trying to solve all sorts of problems. And I think what's exciting is AI in the enterprise is, I think it's the rebirth of IoT. We could almost say it that way, because no longer does IT and spend on technology need to be focused on cost cutting and taking the pain out of things and just trying to figure out how to solve the number of employees. It can be focused on customer service. It can be focused on product development. It can be focused on literally how do we grow the business and rejuvenate the business. So that's the really exciting part. And a lot of the examples that are coming along are doing just that.
What kind of examples then of bringing that kind of value out of IT?
Well, think about it. So, there's products, even companies like Procter & Gamble that are developing products using AI that make it easier to understand their consumer products. So when you're in a retail location and you're trying to find out what skin product to buy, you can take a selfie of yourself. It does auto detect, whether you have crow's feet or dry skin or oily skin, and then recommends the lotions that are appropriate. And they've seen, satisfaction rates go from the 60% up to 90. You have financial banks and companies are doing great improvements on fraud detection.
Right.
Like how many times you've ever used a credit card and you were traveling a lot, so your spending level's gone up, and so they think, oh, you've never been in that location before, so they stop your credit card.
Right.
What do most of us do? I pull out a different credit card and swipe that, so they lose business. Right. So they know they need to actually study the patterns more and really get into what the consumer base is doing with these credit cards to make it better, so that they don't actually pull out that competing credit card and swipe it. So things like that, we're seeing so much in customer service. And I think that's going to be one of the most amazing. And it's because of natural language processing, natural language understanding is getting better. And when you get that level, you can now get to a point where chatbots are going to be so much more successful. And I actually believe, and I'm going to go ahead and make the prediction, I think within a year, most of us are, when we dial in and call customer service, we're going to hope to get that chatbot, or we're going to hope to get... Because who wants to push 7 to get annoyed, 9 to be on hold longer, and go through that whole process, just to come across a human who is authorized to take a bit of information and doesn't have the ability to look it up. Now think about it. If that person on the other line could do quick queries at the speed of thought, subsecond times, and get the information that person is looking for, or if it could just be handled via natural language processing and understanding, it's going to be so much better of an experience.
I'm hoping it's even less than a year. I'm looking forward to that particular future. So interesting. So customer service and definitely in finance, also talking about retail, what are the kind of verticals? What are the kind of industries would be?
Oh, we're seeing just about everything. I mean,
pervasive.
So it's pervasive. And we say retail. Retail started in the distribution centers, right? Distribution centers have been automated like crazy from now. But we're not that far from the smart cart, the smart end cap, as people are walking through. Great companies have been doing great things. I mean, SAP's been strong in retail for years, where they could actually know a lot of information, but now they're going to be automating that as well. And I mentioned SAP because we talk about AI. We always think it's like Facebook, Google, Tencent, these big companies doing it. But SAP's been doing some really great stuff where they sit on an incredible amount of data, very structured data, very well labeled data, and so now they're developing AI applications that are going to be automating every enterprise application we could possibly think of if you're an SAP customer. From service ticketing to invoice processing. We might think it's amazing how long it takes to close a quarter because we're just trying to count the invoices and make it work and balance it between accounts payable, accounts receivable, and the invoice. Right. That should be automated. Yeah. It's just an activity that can and is being automated today.
Now, you mentioned about data sets, and particularly about labeled data sets.
Yes.
Can you describe a little bit there about what the impact is of having a labeled data set?
Yeah, so obviously, when you're training AI, when you're doing deep learning, you're actually doing, the better the data you have, the better the output you can get, right? And so a lot of the process goes into labeling the data sets and actually trying to annotate the data sets and understand what's going on in the data set. So if you already have that done, and that's why we're seeing such amazing activity in healthcare, right? How many retinal scans are already out there, good, bad, et cetera? Right. So if you train a data set up, using that data set, it can tell you amazing things about your health because your retinal is the window to that. Doing the exact same thing in business is where we're going to see a lot going on. I see it in traffic patterns. Network traffic patterns are just patterns. So if you know what a normal pattern is, because watching it, and this is a normal traffic going through, it's much easier to detect an anomaly. So there's a lot going on in cybersecurity. We see an endpoint detection now. We got people like Deep Instinct, Cylance doing that. It's just going to, that's why when you ask which parts of enterprise, it's in every part of enterprise.
Interesting. And it is being brought out to these industries through suppliers like SAP.
Exactly.
Are there other kinds of ways that AI is getting into the enterprise?
Also, the internal developer. The internal, I mean, the developer, I say developer, it's the data scientist becoming, the AI specialist, and they're really upgrading their skills. They're going to things like Deep Learning Institute, and they're learning new skills, and then taking it to the next step. They're being able to download open source components, whether it's TensorFlow from Google, or Microsoft just opened a cognitive toolkit. We do a lot to actually optimize those things and make it much easier to install, so we don't have to go through the 380 some pages of documentation it takes to do these things, and make it as simple as possible. But we're seeing a lot of internal developers, but I mentioned financial services again, the quants of old, who did day trading all day and then actually had to do hand-coded machine learning to analyze their trades, are more and more turning to AI and deep learning. Again, studying the patterns, they have the data of what they've done, and then automating that whole process.
Now that's interesting in terms of workforce.
Yes.
So in that case, with the quants, we're talking about people who are already in this position, they have the domain knowledge. Now they're being augmented?
Yes, definitely. And you just hit the point. The guys with the domain knowledge are the guys that are going to be strong here.
Right.
I mean, we're getting away from the days where when you want to come out with software, it's like, let's come up with a feature set, figure out how I'm going to hand code that, do that for 9 months, do about 3 months of testing and regression testing, and then out 12 months later comes a software release. It's about data. It's about understanding what it is, and you're using data to train and actually come up with the feature sets of it there.
What kind of key technologies then are driving these kind of transformations?
Yeah, one of the cool ones and I've been looking for this to come for years, is basically the ability to understand the data by using deep learning itself and AI itself. So think about it. It's just a pattern. And I have so much unstructured data, and the process of going through and annotating all that data and labeling all that data. And there's crowdsourcing efforts to do that. There's all sorts of ways of doing it. But if AI can learn to label itself and label the data itself and go through the process, and there's companies like Datalog, they're actually making some great strides in this area. And we're seeing it to some degree, right? We started off with image recognition. Remember that was like great. It can recognize a dog, it go from there. But now, more and more, AI is actually seeing the context inside images, right? So you're getting the context and it's labeling images, and that's showing up in social media, but it's also moving into smart cities. It's moving into security, right? So it could actually, at some point, look at our video together and label what we're doing and how we were going about this. So I think that's the amazing component.
Wonderful. That gets into some areas of, say, unsupervised learning.
Yes.
Or I guess another way would be you train a network in one domain, but then can use transfer learning, apply some of the structure into another.
And yeah, so I think we're going from the supervised learning, which I think we pretty much got that under control. Right. We'll be using that with robots for a while, which is a good thing. Yeah. And then I think where we're getting to the unsupervised learning and transfer learning, but also GANs, the adversarial networks, which I think is one of the most exciting areas, because now you have one network trying to be, whether it is learn the style of Picasso as easy as possible, and the other one is trying to fool it. And what comes out the other side is one that's really good at detecting whether it's truly a Picasso or not, and one that's actually really good at imitating the style of Picasso. That's going to move into so many other things. We're seeing Adobe using AI for actually creating the next fonts. If you train a network on all the fonts that ever existed, the next bee's knees is probably going to come from an AI who suggested something like, isn't this a cool idea? Or car designers who are training on all the headlights that ever existed, so when they're trying to think of the next headlight, they can actually brainstorm with an AI, right, and go through that process. So it's really amazing how that happens. And so it is true, there's going to be different approaches for what you're trying to accomplish. And I think we're just at the beginning. I mean, it's only been 4 or 5 years since Alex Krzyzewski gave us this brilliant approach, and I think it's going to be so much more exciting in the future.
Excellent. Any favorite current cases of GANs that you've seen, examples that you like?
Well, facial recognition is one of the best ones, because you need to actually start tricking the ability to recognize it. Because like when we see each other, right? I could probably recognize you with a hat if you change your glasses, if it was a dark room or light room, etc. But if we're just trained on perfect images, we're not going to get there. So we can use GANs to actually try to obfuscate, do different components and make it more difficult. Because if you really want to, and there are companies like SenseTime out of China who want to use your face as a payment capability, right? So if you can do face pay, and you can have the ability to actually recognize with such certitude that that's the right person, whether they have a hat on, glasses, etc. Think about what we can do in security. Think what we can do in things that are going on around Silicon Valley. One of the funniest things that someone explained to me is a great use case that most companies can use today is this idea of tailgating. When someone walks into your company and someone follows you in, if they follow you in and they're on video camera, but you don't actually know if they're an employee or not. If they're not an employee and they tailgated in, you should be able to know that in real time. And the amount of loss that happens inside Silicon Valley and these big companies of people who get in the door, steal a couple laptops, and get out quick is, we don't think about it, but it happens a lot. Sure. So just a simple thing like that will start playing into how we go about our lives.
Any other kinds of enabling technologies that you're seeing on the horizon?
Yeah, so I think just the faster access to data as well. So we have vast amounts of data, and we've stored them in Hadoop and other technologies, and that's great. We're able to extract those out. But if we can get those into solutions that actually give us sub-second access to those, it's going to be much better. I mean, if we're trying to query data to understand it in the data prep process, and it takes me a minute to 2 minutes every query, we think that's no big deal, but that's not real time, and it's sort of frustrating in my process of exploring my data. So now there's more these databases that are living on top of GPUs and other, these technologies are in memory that are allowing you to explore the data much faster. And the faster you can understand your data, the faster you can actually come up with the plans for how you're going to put into your frameworks and do the training in your models.
Oh, excellent. And it seems like that would feed back as well, the example that you were giving earlier about customer service, where if you've got some kind of AI augmentation, the automation needs to be able to look up faster as well.
The future is that there will be constant queries hitting fast databases all the time, coming up with suggestions for us to do things. Once we get to understanding how we want the process to go, and I believe we will change a lot of business processes, because business processes today in the enterprise especially, they're based on workarounds. We've had, anytime we have a technology challenge, or it takes a while to do it, what do? We do workarounds. We do sampling of data, we do downsampling of data, or we do pre-aggregation of data, and then we convince ourselves that we're directionally correct, or enough. Statistically we could justify this, and that doesn't discover the outliers, that doesn't discover the new things. So this new approach that we have fast access to data, and we can have query upon that data, and then we can have AIs do query on that data, is really going to be game changing.
Interesting. In terms of business, this sounds like a classic kind of flywheel scenario where you've got data coming in, you've got AIs operating on it, but then you're also gaining more and more metadata about that.
Absolutely. And think about then what you do is train these smart applications using deep learning and put it at the edge. You don't even need to capture the data anymore. We don't capture 93% of the data at the edge anyway, but with smart applications at the edge, it's going to be the rebirth of IoT. I mean, IoT's been great connecting devices, but having smart applications that can analyze and make decisions on that data is really what we need to do. We'll never be able to capture it otherwise.
That makes sense. I mean, looking at, say, airline, just even monitoring the turbines in flight, I understand that's about 12 exabytes a day. There's no way. But with this, you could actually capture the quintessential parts.
You'll know on there whether there's actually a problem instead of waiting to actually capture the data and do the analysis. If I could actually monitor everything from, wind turbines to drill bits on oil rigs to airplane engines to the flap wings, and know how they're reacting, it's going to change a lot. It's also going to change many of the sensors we do.
Interesting.
So we may just find that the sensors that we've put in place to capture all this data, they're the wrong sensors. And we may actually want new types of data because we now know what we can do with it.
Interesting. So refactoring, putting more smarts into the sensors themselves?
Exactly. Yeah. Smart applications next to the sensors. So they're making the decisions that way.
Gotcha. I'm really interested in the data management part about using GPUs, for instance, to make access to data much faster, and what kind of bearing that would have, say, on the lives of practicing data scientists. So what kind of vendors are out there? What kind of use cases? Can you describe that in more
so
detail?
I mean, first, why are we seeing more GPU-based databases and data management? I mean, for years and years and years, we've seen Dennard scaling and Moore's law pay off for us, right? But we all are starting to see a plateauing of that just because of the physics of semiconductor. You can't actually fit more transistors into that power envelope. So we've discovered by finding parallelisms in that and trying to do that component, you could actually have databases take advantage of that. And NVIDIA started this in 2008 when we launched our CUDA. So a couple of database companies have been around for at least 3 to 4 years doing this on the smaller standpoint. Some came out of government, some came out of other areas. Companies like MapD, Kinetica, there's a new one called BlazingDB, and their whole focus is using that ability to offload what was just the sequential capabilities on the CPU to a GPU, and they're getting incredible processing power. Companies like Verizon are using them for actually monitoring what's going for the SIM card updates. So if you do upgrades to your entire network, and you have to wait several hours to see how it went, it's not the best customer service that you want. So they're seeing that. The Postal Service has used it for actually tracking where their trucks are in the delivery, being able to see things more in real time. And I say real time, but I actually try to encourage people to stop saying real time.
Oh, what do you prefer?
A sub-second.
Okay.
We should, because let's call it what it really is, because real time, as we walk around our trade shows, et cetera, real time could mean anything from 10 seconds to a minute to
ever changing.
Yes, exactly. So. And near real time is another one that actually I don't know what that means. You go out for lunch, I think. So, but sub-second is really, that's the speed of thought. If I can get a query done at the speed of thought, then I explore and I interact with data in a much different way.
Excellent. And so along with IoT then, speed of thought, sub-second, we're talking about really streaming applications here, or what I think
exactly.
people are talking about.
Yeah, so you're capturing streaming data and you can query it. So. And there's great technologies. I mean, people have been using Kafka for years for capturing the data, right? So that's a great technology that I think it will continue to do great things at capturing it. But if you can get it into a database that I can not only query it in sub-second time, I can actually visualize it and find the correlations between it. I think a lot of the graph activity, so there's a company out of Berkeley called Graphistry, allows you to see in a graph orientation all the correlations between this amount of data, like 100x amount of the data you could possibly do before in sub-second times. And people are using that in security a lot. So if I could visualize all the IT attacks or things that I've had from the different IP address and all the connections between them and see that, I could quickly figure out if there's any outlying, dangerous bots sitting out there that are going to try to attack my network when I'm not looking again. And so things like that are just game-changing. I like to think the best part of this is we're letting the security analysts, we're letting the quants, we're all these guys, they get to go home earlier at night because of these technologies. They don't have to stay up all night chasing and finding these things. They can actually go home and have a good dinner.
And all of those areas that you mentioned have changed so dramatically. I mean, we see security issues every day in the news.
Yeah.
We absolutely need to address it.
And security, I think deep learning and AI will solve security. Right now we're using a lot of these fast technologies for understanding what's going on and understanding the data. But it's going to come back to traffic patterns and understanding them and then discovering the anomalies and discovering the approaches to solve those. It's not that different than the game of Go and the champion losing to the computer because the computer was able to study every pattern that ever existed in the game. And they say there's more moves in that game than there are atoms in the universe. I don't know if it's true or not, but there's a lot of moves and different options. So I think it's the exact same thing in a lot of patterns in enterprise and traffic.
Wonderful. So for the person who's in that kind of role, who is a security researcher, they're a data scientist, they're a network engineer, what's your advice for being able to level up and really get in the game with AI?
Yeah, I think the first thing is you have to collect your data. And I'm amazed at how many times I talk to someone and they say, oh, actually we use a service and we don't have access to our data. Make sure you have access to the logs and start going through the logs. Now once you have the logs, you can use some of these tools for exploring it, right? Understanding what the logs are going on, being able to visualize it, find the correlations. But then you should also start labeling those logs in a way and then training. I would spin up a small framework, understanding it, and start just training my traffic patterns, understanding it, so that I can then have an inference and deployment to study when something breaks from that.
Interesting.
And just that's a pretty basic level. That will allow me to start going about it. For endpoints, there are things like Deep Instinct, Cylance would help as well. I expect to see startups coming in this spaces. So a lot of these things people are doing, I expect to see package applications doing this more and more. I mean, there's, how many 6,000 startups being funded right now? We work, we have an inception program. We work with a lot of startups. We have well over 1,500, closing in on 2,000 that are working on it, all in AI, all doing incredible things.
And that kind of focus, too, is a lot about discovery of, again, getting back to domain-specific, the knowledge about your particular area, what your business handles.
Exactly.
Interesting. What about other things that people would need to have in their toolkit? Do they need to learn more about the hardware? Is this more in the software? Where's the...
It's actually an all good and new computing platforms that come along. It's the hardware plus the software. Yeah. Obviously, we're seeing more compute power than we've ever had before, right? I mean, so we are literally, in a land of Moore's law squared in a lot of ways, because it's just so much capacity, which is needed. I mean, we're throwing so much data at this, and we have to process it in parallel. It's like we're driving down the Autobahn of a 10,000 lane highway instead of a country road, and trying to process it all. So I think the hardware is becoming more and more prevalent. I see, every major cloud provider, you can get this level of the GPU computing, NVIDIA GPU computing is available there. But also, it is the software. So we spend a lot of time working with every major framework, optimizing and tuning it and integrating it, and honestly putting it in containers so that you don't have to do all that integration. So if I want to run it on my PC with a Titan X and get the acceleration there, if I want to run it on a workstation, which is the equivalent of like 400 CPUs in a whisper quiet box right next to my desk, which is unthought of. Who would have thought we could have done that like 5 years ago, let alone 10 years ago. Or move it to a data center or move it to a cloud. I can use the exact same software in a containerized component, which is essential because we need to do the training where the data is, right? Because it is kind of a lot. There's a lot of data, and to move it around is difficult. Right. And then when you want to do the inferencing or the deployment, that also has to be where the data is coming in to make the decisions, right? I mean, we don't train self-driving, autonomous driving vehicles to have them sit in your garage, right? They're out in the world experiencing it and doing the data, and they have to be able to handle that out there in the real world. Same in the enterprise, same in everything we do.
So more contextual learning.
It's more contextual learning, and you have to be able to know where you're at. And that's probably the last thing that I think is actually really exciting that's going on. We keep thinking about, what if we don't have the data? Well, more and more we can use simulation. Augmented reality meets deep learning is really opening up doors for so many things. And it's happening in manufacturing now. It has to happen. Well, think about the robots today. Like, we can train pickers, right? They pick something off the line, put it in the box over here. But now think about when that picker is going to be picking up a car, right, or moving something that weighs 2 tons or 3 tons. You don't really want to experiment with that robot in the real world, because something picking up 2 tons, you could knock down the building by accident, in the learning process. So more and more we're seeing these being trained in, another universe, in augmented reality and a virtual reality, and then you take the brain that you train that way and you put it in the physical world. Got it. So that's something that's going to be really essential. Same in autonomous driving vehicles that we work a lot in. You can't find every road or every situation, so at some point, it makes sense to use the gaming approach, the simulation approach to, how I can find every road, every possible scenario.
And of course, that can build on a huge industry in gaming.
Yeah, well, that already is. I mean, we're already seeing people who love the idea of creating that next scene by letting it just, doing the transfer, right, going from there. And I think you're mentioning earlier, the transfer learning is absolutely important there, because eventually, as we do all this work, the automobile guys, or whether it's even the enterprise guys, you have your own data. SAP can create a model, but eventually they're going to have to use transfer capabilities that the enterprise itself has their own data, that they want to augment that intelligence level of that framework of that solution and do it. We know that all the automobile makers are going to do the exact same thing. So that's what's exciting. We talk about a solution, and it applies across 5 or 6 different industries.
Interesting. So to put this into a kind of a landscape, an architecture for enterprises that are embracing AI, we talk about needing to have 3 components: the big compute, the big data, and the big models. Yep. And so that's exactly what you're just spelling out there. Yep. You've got big compute from the hardware and new generation. The bigger the compute, the bigger the model can be, which is the bigger the knowledge you're going to get out of it. Exactly. And the data.
And you need the data. The data is the lifeblood. If you don't have the data, I mean, we train on vapor, we get vapor, right?
Wonderful.
Yeah.
Well, thank you, Jim. I'm looking forward to your keynote at,
Okay.
We're going to have Artificial Intelligence Conference in New York
Yep.
coming up.
No, it should be a lot of fun.
Wonderful. Thank
Okay,
you very
so much.